Hello students, welcome to our class live. I'm your mathematics faculty and today we're going to discuss the quick solutions of AIATS for JEE Advanced 2019, test number 5A paper 1, code A and B. Okay, so this test was held on 17th of February 2019. So this particular paper covers the complete syllabus of JEE Advanced, that is whole syllabus of class 11th as well as class 12th. So let us start the solution discussion with question number 41. It says that the number of points of extremum of the function fx is equal to modulus of x minus 1 minus 2 modulus minus 3 whole modulus, where x belongs to close 0 to open infinity is. So it is a straightforward question based on graph transformations. Okay, so we have to draw the graph of mod of x minus 1 minus 2 whole mod minus 3 whole mod. So let us get started with this. First of all, I have mod of x minus 1, something like this. It will be, this is y equals mod of x minus 1. And I'll shift that downwards by 2 units, so that will give me mod of x minus 1 minus 2. So the graph will be something like this. This is y is equal to mod of x minus 1 minus 2. Okay, so drawing a new x-axis over here, in order to take the next graph, I have the modulus of this function. So that particular graph will look something like this. So this is y is equal to modulus of x minus 1 minus 2 whole modulus. Now you have to shift it 3 unit downwards, or in the other case you can shift the x-axis 3 unit upwards. Okay, so this is the x-axis. We have to shift this graph 3 unit downwards. So let us do it. Students, we know that this particular value is 2. This particular tip will go below the x-axis. Okay, this value being minus 1 now, and the graph is y is equal to mod of x minus 1 minus 2 whole mod minus 3. So for drawing the graph of y equal to fx, let us take another x-axis. The graph will be entirely positive. The negative part will be taken above, as it was taken from the green graph to the red graph. Okay, so finally in orange color I'm going to draw the graph of y equals fx. So finally in orange color I'm going to draw the graph of y equal to fx, that is modulus of the previous graph. The scale will be different. So this will be the graph. This value is 1, this value is minus 4, this value is minus 1, this value is 3, this value is 6. Okay, so we have to figure out the number of points of extremum from close 0 to infinity. So 1, 2, 3 and 4 points of extremum are there. So question number 41 is an integer type question with single integer correct. Answer of this question will be 4. Okay, there are 4 points of extremum in the interval close 0 to infinity. Okay, let us move on to question number 42. Question number 42 says that with the usual notations in a triangle ABC, if capital R into A plus B is equal to C times root AB and small r is equal to A upon mu plus root mu, then what is the value of mu square plus 2? Okay, so let us start this question from the first expression which is given. That is capital R into A plus B is equal to small c into under root of AB. So this will give you A plus B upon root AB is equal to c upon r. Multiplying by half on both sides, I have A plus B upon 2 root AB is equal to c upon 2r, and we have A plus B upon 2 root AB is equal to sin c from sine law. Now students, A and B are positive quantities, they are the sides of a triangle. So apply AMGM for A and B. Apply AMGM for two positive quantities A and B. So I have A plus B by 2 greater than equal to root AB. So we have A plus B by 2 into root AB greater than equal to 1. And this value from this equation, let us say equation number 1, is sin c, and which implies that sin c is greater than equal to 1, which is not possible unless sin c is 1. So if sin c is 1, that means AM is equal to GM, that means small a is equal to small b, that means c equals pi by 2 and angle A is equal to angle B is equal to pi by 4. Because sides are equal, so opposite angles are equal. It is an isosceles right angle triangle now. We have to find out the value of small r. So small r is delta upon s. Delta will be 1 by 2 into A. So A square by 2. And s will be A plus root 2A divided by 2. So this will be A plus A by root 2. So that will give you A upon 2 plus root 2 as the final answer. We can easily see that the value of mu is 2. The answer of this question, that is mu square plus 2, will be equal to 6. Okay, so this is the answer. Let us move on to 43. Question number 43 says that let Ck be an expression which is a definite integral 1 upon k plus 1 to 1 upon k. These are the limits. Sin inverse kx upon tan inverse kx dx. Then what is the value of 4 times limit k tends to infinity k square ck? So let us consider k square ck directly. Limit k tends to infinity k square ck. The value will be limit k tends to infinity k square into integral of 1 upon k plus 1 to 1 upon k sin inverse kx upon tan inverse kx dx. So students, let us substitute kx as t. Put kx as t, which will give you dx as dt upon k. So we'll have in the next step limit k tends to infinity k square, the limits from 1 upon k plus 1. So if x is 1 upon k plus 1, t is k upon k plus 1. And if x is 1 by k, t is directly 1. So limits are changed, one limit is constant now. This is sin inverse t upon tan inverse t dt by k. So which will give you limit k tends to infinity k integration of k upon k plus 1 to 1 sin inverse t upon tan inverse t dt, which can be written as limit k tends to infinity integral k upon k plus 1 to 1 sin inverse t upon tan inverse t dt whole divided by 1 upon k. Students, what I am trying to convert the things into, I can see that as k tends to infinity, this limit is tending to 1. So from integral 1 to 1 of any particular function inside over there will be 0 because the limits are same. So that means numerator is 0, denominator is 1 upon k, that also tends to 0 when k tends to infinity. So it is 0 by 0 format, which means that I can apply L'Hospital rule over here. So let us apply L'Hospital rule over here. Limit k tends to infinity. The differentiation of 1 is 0. So 0 minus differentiation of k upon k plus 1. So k plus 1 whole square. Over here I will have k plus 1 into differentiation of k, that is 1 minus k, multiplied by the functional value of this limit. So sin inverse k upon k plus 1 upon tan inverse k upon k plus 1. Sin inverse k upon k plus 1 whole divided by tan inverse k upon k plus 1. And both of the limits are finite because it is sin inverse 1 upon tan inverse 1 whole divided by the differentiation of denominator minus 1 upon k square. This gives you limit k tends to infinity. This is a finite value, no doubt. The numerator is negative of 1 upon k plus 1 whole square. This is minus 1 upon k square. This is k square upon k plus 1 whole square, which reduces to 1. Sin inverse k upon k plus 1, which reduces to pi by 2. And tan inverse k upon k plus 1, which reduces to pi by 4. So the answer of this limit is 1 into pi by 2 divided by pi by 4, which gives you 2. This is the answer of the limit. The question is asking you 4 times the value of the limit. So the answer to the question is equal to 8. Okay, single integer type. Let us move on to 44. Question number 44 says that let circles C1 and C2 on argand plane be given by modulus of z plus 1 equals 3 and modulus of z minus 2 equals 7 respectively. If a variable circle mod of z minus z0 equals r be inside the circle C2 such that it touches C1 externally and C2 internally, then the locus of z0 describes a conic E. If the eccentricity of E can be written as the simplest form of P by Q, where P and Q are belonging to natural number, then what is the value of Q minus P? Students, so C1 is modulus of z plus 1 equals 3, which gives you x plus 1 whole square plus y square equals 9. C2. Modulus of z minus 2 equals 7, which gives you x minus 2 whole square plus y square equals 49. The center of first circle is minus 1, 0, C1. R1 is equal to 3, C2 is 2, 0, and R2 is 7. So let us draw the circles. So this blue circle is C1, green circle is C2. We have the C1 circle lying completely inside C2 circle. Now we need a circle which is lying such that it is touching green circle internally and the blue circle externally. So there will be infinite such circles, no doubt in that. There will be so many circles of this type, something like this. We need the locus of the centers of all such red circles. Okay, so you can easily see that if the center of this circle, new circle, C3 is h comma k and radius R3 is, let us say, R, you can easily see that C3 C1 is equal to R1 plus R3, so that is R plus 3, and C3 C2 is R2 minus R3, that is 7 minus R. So you can easily see that C1 C3 plus C2 C3 is equal to 10. That is the locus. So from these two equations, if you want to eliminate R, you directly add them. So we will get C1 C3 plus C2 C3 is equal to 10. And that is the locus. Sum of distances of C3 from C1 and C2 is equal to 10. So we have directly 2A is equal to 10. And the foci are C2 and C1. So 2AE is the distance between the two foci. Distance between C1 and C3 is clearly equal to 3. So we have eccentricity directly as 3 upon 10. Okay. So if eccentricity is 3 upon 10, what is the next step? Q minus P. So 10 minus 3, 7 will be the answer for question number 44. Okay. Let us move on to 45. Question number 45 says that a pair of variable straight lines 5x square plus 3y square plus alpha xy equals 0, where alpha belongs to real, cut the parabola y square equals 4x at 2 points other than origin, obviously, because this is a straight line passing through origin. So the other 2 points are P and Q. If the locus of point of intersection of tangents to the given parabola at P and Q is given by x equals P by Q, where P and Q are co-prime to each other, then the value of P minus Q plus 2 is equal to what? Students, the locus of the points of intersection of tangents to the parabola at P and Q, let us say the point is point M and the coordinates of point M we assume as h comma k. Now PQ will be the chord of contact with respect to point M for this particular parabola. So for PQ, we can use equation T is equal to 0 with respect to point M. Okay. Now, so for PQ, the equation will be ky minus 2 times x plus h equals 0. So 2x minus ky plus 2h equals 0. This is the equation of PQ. The pair of variable straight line is the pair of lines which is joining origin to P as well as to Q. So that means these pair of straight lines can be obtained by homogenizing y square equal to 4x by using this particular line. Okay, so we have by homogenization y square minus 4x into the value of 1 is that we substitute. So 2x minus ky upon minus 2h is the value of 1 equals 0. This will give you the equation of the pair of variable straight lines joining origin to P as well as to Q, which is the point of intersection of chord of contact and the parabola. Okay, so we have 8x square minus 4kxy plus 2hy square as the equation of variable straight lines. So we have to compare it with the given pair of straight lines, that is 5x square plus 3y square plus alpha xy equals 0. By comparing, what we will get? We'll straight away get 5 upon 8 equals 3 upon 2h equals alpha upon minus 4k. Students, have a careful look. The locus is x is equal to p by q. From here, I'll get the value of h as 12 upon 5. So the locus is x is equal to 12 by 5. This is the final answer of the question. We have to answer p minus q by 2. So p is 12 minus q is 5 plus 2. The answer will be equal to 9 for question number 45. Okay. So a very conceptual problem involving two concepts, equation of chord of contact with respect to external point, as well as homogenization, as well as finding out the locus. Okay. Let us move on to 46. Question number 46 says that the position vectors of 2 points A and C are 9i cap minus j cap plus 7k cap and 7i cap minus 2j cap plus 7k cap respectively. The point of intersection of the lines containing AB vector and CD vector is P. So we have lines containing AB vector 4i cap minus j cap plus 3k cap and CD vector 2i cap minus j cap plus 2k cap is P. Now students, we are given point A, we are given direction ratios of AB. So we know the equation of line AB. Further, we are given the point position vector of C, we are given the direction ratio of CD. So we also know the equation of line CD. So we know the point P ultimately. If a vector PQ vector is perpendicular to AB vector and CD vector, so AB and CD direction ratios are given. So PQ, you can easily calculate the direction ratios. From there, you can evaluate the coordinates of point Q because PQ is already given to be 15 units. So this question is very easy. The possible position vector of Q are x1i cap plus x2j cap plus x3k cap and y1i cap plus y2j cap plus y3k cap. So there are two possibilities for point Q that they are already telling you. Then what is the value of summation I from 1 to 3 xi plus y is equal to? First of all, R1 vector, which is describing the equation of AB, will be 9 plus 4 lambda I cap plus minus 1 minus lambda j cap plus 7 plus 3 lambda k cap, which can be alternatively written as 9i minus j plus 7k plus lambda times AB vector, that is 4i minus j plus 3k. Similarly, R2 vector for CD, I have 7 plus 2 mu I cap minus 2 minus mu j cap 7 plus 2 mu k cap. So for solving R1 and R2, we get point P as 1, 1, 1 or I cap plus j cap plus k cap. Now the direction ratios of PQ will be obtained by AB cross CD. That means IJK 4 minus 1 3 and 2 minus 1 2. The direction ratios are. Now what we'll have? We will have here I cap minus 2j cap minus 2k cap. So students, the DRs can be 1 minus 2 minus 2 or minus 1 2 2. You can see that if I take the magnitude of dr directly, it will be equal to 3. So I have to multiply them 5 times in order to get the coordinates of Q with respect to P. Okay, so Q can either be P plus 5 times this. So 6 minus 9 or minus 4 and 11. These are the two possibilities for point Q. Okay, so we have the summation of all 6 is the answer. Pairwise the summation is 2, 2, 2 for abscissa, ordinate and applicate. So 2 plus 2 plus 2. The answer is equal to 6 for question number 46. Okay, so a very simple question just based on the concept of direction ratios and the cross product over there. So we have 6 as the final answer. Let us move on to the next one.